All right, on this video, we are going to identify a rational function from its graph. So, and it tells us in the directions that these are all transformation of 1 over x. So it's going to look sort of like this. Now, the transformation form for this type of rational function, by the way, there are lots of rational functions. There are other parent functions. We could have like 1 over x squared or 1 over x to the third, etc. But this is the most basic. All right, so here's our transformation form. All right, and yeah, just really quickly, this is left to right shift, up and down shift, and then A indicates either a stretch, vertical stretch, and I should say. It also shows if there's a reflection over the x-axis. All right, so looking at this, we have the first thing I would want to do, once we find all these values, we can write the function. So the first thing I'm going to look at is see, well, what are the translation amounts? How much did it get shifted left or right, up or down, right? The fancy word for shifting is translation. So it looks like it got shifted 1 left and 2 down. So let me write that down. So 1 left and 2 down. So that means that h is -1, okay? And then this means that k is -2, all right? So I have that. Now I just need to find a. And so what I need to do that is one of my reference points on the parent function is 1, 1. And if I can see how 1, 1 has changed on this transformed graph, I can get the stretch value. First of all, I should be able to go right 1 and up. I can tell there's no reflection here. Otherwise, it would be, this part would be down here, okay, and then this part would be up here. So it looks like right 1 up 1, 2, 3. So that means this has been multiplied by 3. And so that means I have a vertical stretch by 3. And that means a equals 3. So I basically have my function now. I just plug all those values into here. So I'm going to have g of x equal to 3 over x minus a -1, which will look like +1, and then plus k, which I'm just going to write that as -2, plus -2. Same thing as -2. So there we go. That's how that works. All right, you guys go ahead and do number 7. Okay, so I got g of x equals -2 over x plus 3. By the way, I guess a slightly more preferred way to write this is to put that negative out front. Really, both mean the same thing, but this is, I suppose, a little bit more preferred. So, yeah, I first identified my shifts here. So left 3, down 2, so those are the values of those variables. There was a reflection here. If you go right, it's not up, it's down instead of up. So I knew there was a reflection over the x-axis, and I saw, well, from here, how many, again, it's based on this reference point of 1, 1. Instead of going over 1, up 1, I had to go over 1, down 2. So that means a is -2. Negative because of the reflection, 2 because of the stretch. And so that's why -2 goes up here. And then, of course, my h and k go here and here. Careful when you plug in -3 and for h, it becomes positive.